Okay, welcome everyone. We're happy that you're here. You're joining our MSU Science Festival, Disappearing Leaves and Moldy Bread, and we'll wait about one more minute for additional people to join us through Zoom or Facebook. But if you're online with us now and you'd like to join us on our slide deck, the bit.ly is bit.ly/leaves with a capital L, bread with a capital B. Or if you're here with us in Zoom, we put the link into the Zoom chat so you can find it there. All right, again, if you're just joining us, we are Disappearing Leaves and Moldy Bread here at the MSU Science Festival this evening. And if you'd like to join us in our Google slide deck, you can use this bit.ly. It's bit.ly/leaves with a capital L and B with a capital bread. Or if you're here with us on Zoom, we have the link to the Google slide deck in the chat. It is not necessary to open that slide deck, but sometimes our participants like to follow along. And I'll go ahead and get started as we're just after 6 and we have just a little bit of time with you tonight. So as you join us to figure out what's happening and how we can make sense of these yucky natural events, I can introduce myself. I'm Christie Morrison Thomas, and I work at Michigan State University with MSU's Create for STEM Institute. And I'm joined tonight with my friend and colleague, Angie Kalanish, also at Create for STEM. Both of us work with the Next Generation Project-Based Learning Initiative, and I work specifically with the Carbon Time Project, which stands for Carbon Transformations in Matter and Energy. And the ideas and examples that we have tonight come from the Carbon Time curriculum. So our agenda is to talk about some yucky ideas and experiences. We will share how to design some experiments at home, but you don't need to have any materials with you right now. We'll think about what happens to dead leaves, and then I'll share some additional resources if you'd like to learn more after we are together tonight. So to start with, totally gross examples of some molding fruit. Here is a yucky orange. You can see it's white and green sort of mold growing here. You can probably imagine touching it, and I certainly have in the past touched things like this. They're squishy and kind of soft. Here's an example of some tomatoes with that white fuzzy cotton-like mold growing on the fruit and the vine. And we're going to take a look at this really cool, really gross example of grapes molding with a very short video here. So this video, I'll share with you, it's less than a minute, and Angie and I will talk a little bit about it as we watch it. This is a time-lapse video. Pictures were taken every 15 minutes over 10 days at Cornell University. So Angie, what do you notice?
Oh, wow. The grapes, they're kind of turning brown and they're almost like growing fuzzy. And it looks like there's little dots in there. Oh my goodness.
Right? So gross. And now we see this black stuff in the middle, and there's like something dripping on the side. Ew, it's about to fall, I think, onto the ground. Ugh. And it's like all the grapes are like leaning backward, sort of shrinking. And it looks like these 2 grapes here at the beginning or at the front, it's sort of like they disappeared. Ugh. So gross. So now that we've looked at those yucky examples, we wonder a little bit about examples you probably have had, times you've seen, maybe touched, even smelled something like these examples. And you can take a minute, think about your experiences in your head. If you're here with us on Zoom, you can type them into the chat. If you're joining us on Facebook Live, you can type them into the chat there. You can just talk out loud to the people in the room with you. What are some examples that you've had really yucky experiences like these oranges, tomatoes, or grapes?
Can I share mine, Christy?
Please, Angie.
So this would be one time I let a bag of bagels out a little bit too long and I didn't know it, and I put it in the toaster and cooked it, and I took a bite and it was not a solid bagel. There was mold in there and it was super gross. I wanted to share that. This was recent.
Oh, Angie, thank you for sharing that. That sounds awful. I'm really sorry. What a difficult start to your day. We have Steve here sharing about bread that appears different colors. Sue is sharing with us that she found some salmon that had been hiding at the back of the fridge. We have Rini talking about a banana, and it's like the rind is turning sort of brown, so it's maybe not molding yet, but it could soon. Chelsea, do you have anything that you want to relay from Facebook Live before we move on?
I do not see anything yet, but we do have a little bit of a delay on Facebook, so I'll let you know if we do have anything. But something that always makes me really sad is when my cherry tomatoes are moldy at the bottom of the container, and then I realize, like, oh no, then my cherry tomatoes went bad because then I can't see them all.
Yes, that's such a good point, and so disappointing because the ones at the top look great, and then at the bottom, here they are looking like these tomatoes, or even like the grapes sort of turning liquidy. Ugh. So thank you for these examples, and what we're going to do next is take a look at how we could learn more about these sort of yucky and molding experiences. So one of the ways that scientists learn more about something are by designing and carrying out investigations. And what I want to show you first is another 1-minute video clip. Here we're going to be able to see, this is from our Carbon Time curriculum, Daryl and Nina set up an experiment with molding bread.
Right, and today we're growing bread mold.
Hey, Nina, have you heard the buzz? Today we grow fuzz.
Oh boy. Hey, Daryl.
Nina, behold, it's time for mold.
Ugh, please don't tell me that you're a fun guy.
Nice. I won't. But we will have a fungus among us shortly, because we've been growing bread mold, which is a fungus that grows on bread. Mold is alive, and it grows.
So, since it takes about a week for the bread to mold, let's flash back to when we started this investigation. We started by putting some moist bread in Petri dishes.
Then we weighed the bread in the Petri dishes. Our bread started out at 39.5 grams. That's before the mold started growing. That's right in line with the sample data from another classroom.
Then we waited for the bread to mold. It took about a week. This bread's looking nice and gross.
Ew.
And that's where we'll stop sharing Daryl and Nina and return to setting this up at home if you would like to. So again, you don't need these materials in front of you right now, but if you'd like to try this later at your house, all you'll need is a piece of bread, something like this. Generally, bakery bread works better because it tends not to have preservatives, and the preservatives actually keep mold from growing. So you'll want a piece of bread and you'll want some kind of container, and then you can just spray the bread with some water to make it damp and wet. If you don't have a spray bottle, you can splash water on it with your fingers. You just don't want to soak the bread. And then you'll put a lid on it that can keep it airtight. And like Daryl and Nina said, it'll take about a week to see changes. If you don't have a scale at home to record changes in mass, you can use this video, because later in the video, Daryl and Nina will tell you how their bread and mold changed mass over time. They'll also show you what happens to a chemical called bromothymol blue, or BTB for short, and that's a special indicator that lets us know how carbon dioxide is changing in the air. So all of that is available for you in this video and in this investigation worksheet. Now, something that you may or may not have thought about before is that these yucky examples of like moldy food, like our grapes and cherry tomatoes and salmon, they actually have a lot in common with dead leaves. There are two reasons these things have like the pieces in common. One of them is that mold on that moldy food is the same kind of living thing as these mushrooms growing in the dead leaves. Or like you heard the words fungi and fungus among us in the Daryl and Nina video, all of these words, mold, fungus, mushrooms, they are examples of decomposers, which are multi-celled organisms that use things like, dead leaves for food. Another way that dead leaves and these moldy food are kind of the same is they both can seem to disappear. Like the grapes in our video sort of shrunk over time, and dead leaves seem to disappear over time too. So let's see if we can figure out a little bit more about what happens to dead leaves. And to do that, we're going to use something called a big idea probe. This comes from our Carbon Time curriculum, and this is an example of a classroom in Wisconsin that set up a different kind of experiment. So I'm going to read this introduction to you, and then some different student ideas, and then we'll put a link in the chat where you can go to vote for the student that you agree with. Or if you're joining us on Facebook Live, you'll be able to use the chat feature if you're not in our slide deck. So let me start by going over this setup. So Miss Lynn teaches science in Wisconsin. Her class has been working on a leaf peck experiment. In the experiment, the class gathered dried leaves from trees outside their school, and then they placed those leaves in a mesh bag. So there were holes where water and air could go in and out. The mesh bag with leaves weighed about 50 grams. That's about as much as like a small bag of chips. So the class put their leaf pack under a rock in a forested area, and then they waited. In fact, they waited like a whole month. And then they went out and retrieved. They took back that leaf pack, they dried it, and they measured its dry mass. But before they did that, Miss Lynn asked her students to make a prediction about what they think they'll observe. And here's what some of the students thought. Marco thinks the leaf pack will gain mass because decomposers, like that mold and mushrooms in the soil, will grow on the leaves. Jessie thinks that the leaf pack will lose mass because the leaves will naturally break down and the mass will disappear. Andre thinks the leaf pack will lose mass to the air because those decomposers will use the leaves for cellular respiration. May thinks that the leaf pack will lose mass to the soil because leaves are dead and they'll decay into the soil over time. And finally, Kara thinks that the mass of the leaf pack will stay about the same because decomposers will gain mass while the leaves lose mass. So now we want to know, who do you agree with and why? So you can use this Google form to vote. And in a second, Angie or I will put this here in the chat. And you'll have the opportunity to pick one or more of these people that you agree with, tell us a little bit about why, and then click submit. And remember, or maybe I didn't say this already, but there's no right or wrong answer right now. There's just your ideas and who you agree with. Okay, let me see if I can get this into the chat for you. There you go. So if you're here with us on Zoom, you can, on our Zoom webinar, you can use this link to access the Google form and make your vote. If you're joining us on Facebook Live, you can use that chat feature to tell us Marco or Jessie or Andre or May. Or if you're in the slide deck with us, you can use this link. We'll wait while you think a little bit about who you agree with, and we see what kind of votes are coming in. Oh, thank you. And Chelsea, our MSU Science Fest support, is putting this Google form link straight into the Facebook Live chat. So if you're joining us on Facebook, or if you're joining us in our Zoom webinar, find your chat and you'll see a link to this Google form. And what I'm going to do is move our form view so that I can begin to see responses as they come in. We'll wait a minute or two and talk about some of your ideas. And then we'll talk about how to set up this experiment at home if you want to, and how to find out more if this is really exciting. Okay, awesome. So we're starting to see some responses. Thank you. We've got some different ideas about who you agree with and why you agree with them. So for instance, some of us are thinking that Kara and Andre's ideas make sense because it makes sense to us that the leaf pack will lose mass. And Kara and Andre have ideas that make sense to us. Like for example, Kara was thinking that things might stay about the same overall, and Andre is thinking that the decomposers might lose mass, or the leaves might lose mass to the air because of the work the decomposers are doing. In fact, it looks like a lot of us right now agree with Andre, although we see ideas spread across all of our students. Angie, is there anything you want to add out loud before we go back to our slide deck?
The only thing I think I would add is that my thought is that maybe leaf bag would lose mass like the grapes. That's an idea that I was thinking, but I'm not totally sure which person I fully agree with.
That's an excellent point. Thank you, Angie. And you might be feeling similarly to Angie, that as you look at these choices, like you see things across students that make sense to you and that you agree with. So we'll go ahead and move on as a group, but if you're still thinking about your idea and you'd like to send in your vote later, that voting form will stay open and we're happy to hear from you. So as we think about Marco, Jesse, Andre, May, and Kara, they're experiencing this with their classroom at school, but this is also an experiment that you could set up at home or possibly with your peers and your teacher at school. And the setup is described here in that big idea probe that I read out loud. And really all you need are some dead leaves and like a mesh bag and then some time to wait. So you are very welcome to try something like this at home. Again, if you don't have a scale at home, there are resources online that can help you, or you may be able to use one from your classroom. So if you're interested in exploring more, like these grapes and tomatoes and these different ideas about what happens to dead leaves have sort of piqued your interest, check out these resources. Our Carbon Time unit on decomposers is available online and linked here. And it has resources for making sense of these kind of phenomena like moldy bread and disappearing leaves by tracing matter and energy through living systems. On this slide, I listed a few activities that have supports that make sense, I think, even if you're not working through the whole unit with your peers or classroom at school. And I'll show you two quick examples before we wrap up. This is a reading about one of my colleagues at Michigan State University. Her name is Dr. Ellen Holsta, and she has her PhD in forest ecology. And here she writes about her experiences studying fungi in a forest. She talks about questions that she asked, how she designed and carried out investigations, and then how she used evidence and models to construct an explanation for what was happening in this forest with this fungi. So really, really great experience from someone right here in Michigan. Another really neat worksheet or activity that you might be interested in at home is about useful decomposers. So far tonight we talked about mold, fungus, mushrooms. These are all decomposers we can see with our eyes. But another kind of decomposer we can't see with our eyes are bacteria. And you've probably heard about bacteria. Many kinds of bacteria are very, very useful for people for things like food and other sort of human processes. And this worksheet gives you a little bit of information and some suggestions on how to learn more. So that really wraps us up for tonight. As we exit, we'll share one more slide that has information about all the kinds of work my colleague Angie and I do at Michigan State University at the Create for STEM Institute and with the Next Generation Project-Based Learning Initiative. So if you are interested in other kinds of curriculum or grade levels, those things are available for you here. Angie or Chelsea, are there any questions in our chat or other locations that you want to raise for us to talk about together? No, Angie says no. I think Chelsea's looking.
There's nothing I see in the Facebook right now, but I thought that this was really cool, honestly. I never really hear people talk about mold in this context, and I really appreciate you talking about this with us, especially like as projects that people can do with their children. This is very innovative to me, and thank you.
Chelsea, you're welcome. Well, we really appreciate the opportunity to join the MSU Science Festival this year. And for all of our attendees and participants, thanks for taking some time this evening to join us and to participate. And please reach out to the MSU Science Festival or us here at NGPBL if you have questions that we can answer after tonight.
Yes, thank you so much, Create for STEM, for joining us, especially you, Christie and Angie. And everyone else, I hope you'll still join us for the rest of MSU Science Festival. Today we have a lot more presentations, and we have presentations for the rest of the month too. So thank you so much again. Have a great day, everyone.
Thank you. Bye.